In this collab, we are going to learn the three different deep learning, especially for the sequential data. The first is the RNN, and next is GRU, and next is LSTM. For the deep learning, there are several libraries. I think you already do some of this one in the other class, but let me review a little bit. So you can use the TensorFlow. We have the library like Keras, and you can just reuse the existing tools like the sequential, simple RNN, GRU, LSTM, and also we can use how we want to create the layer and how we can create the text embedding. And in the Keras, they also have a function for tokenizer, and there's also a function about pet sequences. So we will take a look what is this function. Now let's take a look how we can define the data. So let's say this is the toy data. In this case, we have 4 sentences. This is the first document, and then this document is the second document, and this is the third one, and this is the first document with question mark. So we have 4 sentences. As you may know, we need to do the pre-processing. So the pre-processing, we can do like sentence tokenizer or word tokenizer. For this one, I will use the tokenizer given by the Keras, and we are making a tokenizer. This is an instance from the class tokenizer, and then I would like to fit this tokenizer on the text data. So the text data is this one, and I'm going to look at the total words. So how many the total words? Okay, we have 10. How can we calculate 10? So this is from this document. This is a very small data. Okay, we have this is the first document, so there are 5. This, because we already have this, then we do not calculate it. Document, we already have document, so we do not calculate it. Is, we already have is, so we also do not calculate it. The, we already have the, so we do not calculate it, and so on. So we want to know the unique word or the unique sentence in this case. But yeah, let me just use the unique word in this case. So if you run this, you will see there are 10 words, and each of the word will be indexed. It is the index from every word. So it is randomly generated by the Python. So for example, this, the index is 1. Is, the index is 2. The index is 3. Document, the index is 4. First, the index is 5, and so on. Now, we are going to create the input sequence, and we can create a kind of label. As you know, if we have a data, if we have a data table like this one, so we will create the table, and then one of the column will be the class, or we call it the target. Yeah, it depends on what is the purpose of your machine learning? What is the purpose of your analysis? If you are going to do the classification, then the class will be a categorical data. If you are going to do the regression, then the class will be numerical data. So let's say I'm going to make some kind of text classification or text generation. In order to do the text classification, so I want to know whether the sentence belong to one class. Let's say you already did in your assignment 1, whether the title of the news, whether it is clickbait or non-clickbait. We can also do this kind of deep learning for text generation. The text generation means I want to know what will be the next text. What is the next word? So in this case, I want to know if I have a data, I have a sentence. This is the first. So I want to know what will be the next word. You already learned from the previous section, we can do like the probability. We can do with some other approaches. Now let's look at how the deep learning can work for this text generation. So we have the index. Every word will be indexed into a number. 1 is for this, 2 is for is, 3 for the, 4 is for document, 5 is for the first, 6 is for the second, and so on. Now I would like to create the input sequence. So this input sequence means I would like to make the data according to the text. Let's say the first text is this is the first document. Then what I will create in this input sequence is I would like to check every line of the data. For every line in the data, I would like to check the text to sequence. It means I would like to get the data for every line and let's split it. So if I have like this is the first document, okay, then I would like to get this is the first document. So we can have the token list. And after that, we want to make the n-gram. I guess you know already the n-gram means whether we have the n equals to 1, which is unigram, or n equals to 2, which is bigram, or n equals to 3, which is trigram, and so on. So this n-gram will be a list from, it is a list from the beginning until I plus 1. So it means we are going to make a loop and I will be from 1 until the length of the token list. So if I have the word, this is the first document, then I will do the loop from 1 until 1, 2, 3, 4, 5. So I will make the n-gram sequence, and for every n-gram, it will be append into the input sequence. So it means I will have a new list. So let's see if I run this. So the token list is Yeah, 2, 1, 3, 5, 4. What does it mean? Two, 1, 3, 5, 4. So you can look at the index. The index 2 is the index 1 is this, the index 3 is the index 5 first, the index 4 document. So you can see this one. Is this the first document? So it is the sequence of the text data, and this is the last one. Then if I want to know all the input sequence, then I can have this data. So the data will be in the sequence like this. And if you know, this is for the two words, 1 and 2. 1 and 2 means I have this and is. 1, 2, and 3. We have this is the 1, 2, 3, and 5. So this is the first. 1, 2, 3, 5, and 4. So this is the first document. So every of this word will be indexed into a list, and we are creating this list for all the documents. Then you can understand that this feature will be very long. And after we have this one, you can take a look on the detail like this one, 1, 4, 1, 4, 2, 1, 4, 2, 2, 1, 4, 2, 3, 6, 1, 4, 2, 3, 6, 4. It means that we are making the data based on the index 1 for this document, 2, 3. This document is the second document. This document is the second document based on the index. And after we have this data, now we want to check the length. The maximum length. What is the maximum length? So the maximum length will be based on the longest data. In this case, I have the 1, 4, 2, 3, 6, 4. So this is the longest data. And we are making the input sequences. So the input sequences, we are making it aligned. So yeah, in the assignment 1, you know that the number of text, the number of words in the training and the testing, they are different. Okay, so you have your own idea. So you combine the training and the testing set, and yeah, there is another way. This is the alternative. We can use the PET sequences. So what is this one? We can make this sequence based on the maximum sequence length, and some data will be PET. So what does it mean, this one? If you look at the maximum sequence length, so there are 6, you know, we have 1, 2, 3, 4, 5, 6. Okay. And the input sequence now become 6. The first data now becomes 0, 0, 0, 0, 1, and 2. The second data now becomes 0, 0, 0, 1, 2, and 3. The third data now becomes 0, 0, 1, 2, 3, and 5. So every data we have 6. Why do we need to do this one? Because we need to have the same length data. Whenever you put the data into the machine learning, into the deep learning, yeah, you need to have the same sequences or the same length of the sequences. So we are using the PET Okay, we are using the path sequences in order to make the length equals. So I give you another example here. So let's suppose we have 5, 8, and 15. And then we have 12 and 7. And we have 3, 9, 14, and 6. So the length of this one is 3. The length of this one is 2. And the length of this one is 4. In order to create the same length, then I can use the path sequences. What I want to do is to check the sequences as the input, and I want to make the maximum length equals to 4. So the maximum length equals to 4 means I want to make all the length equals. The maximum is 4, then I want to make this equals to 4, I want to make this also equals to 4. Then I can define the maximum length equals to 4, and the padding is pre. So pre means I would like to put the additional data, which is 0, in front of those data. So if I have this one, so I have 3 data, and then I'm using the TensorFlow path sequence to make the length of the data equals. Then all the data now becomes 4, the same length. And we put the additional data in the pre. Pre means the data before. You can have some alternative. For example, you want to make post. Okay. So we can use post, means we can put the data after. So 0 will be after the data, which is 5, 8, 15. And the second data we have 12, 7, and we have 0, 0. And the last data we have 3, 9, 14, and 6. It is the same. It remains the same. Because we have the maximum length is 4. If we change the maximum length into 6, what happened? If we change into 6, then we have 6 data, and because we put the padding post, then there will be additional data at the end. So we want to make the data equal like this one, and after we have the structure data, we will create the training set and the testing set. So I think the idea is the same with the assignment 1. We can create the same length of the training and the testing, and then after that we can do the machine learning. So in this case, I would like to make the x. The x is this one. The x is the first data, and then the y is the last column. Why? I want to generate a sentence. I want to generate some kind of text or document, and I want to know if we have a particular text, let's say the index is 1, so what will be the next word? So the next word is 2. If I have the word 1 and 2, what will be the next word? The next word will be 3. If I have the word 1, 2, and 3, what will be the next word? So I can have the next word is 5. Then I can say that this is the y, or this is the class, and this is the x. Given X, I can know what will be the best prediction or what will be the best word after we have the X. Then the X will be every data from the input sequence from the index 0 until -1 or before the end of the day. And the Y will be the all data that is the end of the column. This is the answer. So we can make the data. Now we have the X. So the X will be this 0, 0, 0, 0, 1. And then I make the Y as a categorical or it is an array because it will be easier for the computer to understand the column here. If you use 2, 3, 4, 5 like this one, yeah, it will be multi-class classification. And if you use this number, the result will be like the regression or something about the numerical. And we want to make the multi-class classification by creating a categorical data. And we are making the total words into the number of classes. Because every word can be a class. Every word can be generated. After we have this X, so we create the Y. So this is the Y. So how to interpret this Y? The first one, how to interpret this one? This is, if you look at the data, the index is 2, and then the index is 3, and then the index is 5, and so on. So 2, it means that, yeah, we have 10 data, and then it is located in the position 2. We have 10 data, the second class, it is located in the index 3. We have 10 data, the third class, it is located in the index 5. In the fourth data, the class is located in index 4, and so on. So you can look at the data. So the first data, the class is index 2. The second data, the class is index 3. The third data, the class is index 5. The fourth data, the class is index 4, and so on. Then we will create this kind of Y to indicate the class. And after we have this class, we can do something about the deep learning. So we can put the data into the model. Let's use the simple RNN. So the simple RNN means I will use the sequential, and then before we do the simple RNN, we need to create the embedding or the word embedding. In this case, we are making the embedding based on the total word, which is 10. And yeah, 50, it can be, yeah, this is the output dimension. And then what you want to check for the maximum sequence length. So the total word that we have is 6, and I want to create the input length as 5. Because if you have the 6 data, but in effect the X we have only 5. So 6 minus 1, 6 minus the class. Now it becomes We have the simple RNN, and then this parameter you can define by yourself. This is the number of layer. You can have 100. Of course, if you make it higher, the computation will be higher. And we have tens. So we are making the, after we do with the multiple layers, we want to check for every layer when we make the output, we want to use the activation function, which is the softmax. So the optimizer means there will be a way to optimize the function, and the loss function means I want to know the gap between the training data and the result, and the metrics. So what are the metrics that we want to show? This model RNN will fit into the X and Y, and it will run for 100 epochs. So I guess if you join the data mining, you will learn about those stuff. And there are some alternatives. You can make some alternative, not only with the Adam optimizer, but you can use SGD, stochastic gradient descent, or you can use some other alternative like RMSPROC, which is the root mean square propagation, AdaGrad, adaptive gradient algorithm, or AdaDelta, an extension of AdaGrad, AdaMax, which is a variant of Adam. So this is the optimizer. So you can change the optimizer. And also you can change the loss function. So the loss function, there are several loss functions. For example, if you are doing with the multi-class classification, you can use the categorical cross entropy. If you are using the binary classification, you can use the binary cross entropy. So this is for the binary classification problem. Or you can have another choice. For example, you want to do with the sparse categorical cross entropy. So we can use this one. Usually if your data, there are a lot of zero. Or in the recommendation system, if we have the rating and the rating is very sparse, then we can use this loss function. We can apply with the regression loss function like mean square error, mean absolute error, or we can use advanced loss function, for example, hints or square hints. This is the maximum margin classification task. Let's say you are using SPM. So yeah, we can apply the SPM task to calculate the hints and the square hints. We can use another loss function like KL divergence, the Colbert-Leiber divergence. It is based on the probabilistic models, and it is to measure the divergence between two distributions. Or we can use the cosine similarity. So we want to see the similarity between the result and the previous layers. So this we want to see the similarity between the predicted and the true vectors. So if the similarity is big or the similarity is high, then we can say the predicted and the true vector, they are the same. For the matrix, there are some other alternative. Now you can see the example. I used only the accuracy, but you can use the categorical accuracy or sparse categorical accuracy, or you can use binary accuracy. So the categorical accuracy is for the multi-class classification, for the binary accuracy, it is for the binary classification. So you have only two classes. Some other choices, for example, precision, recall, advanced score, AUC, mean square error, mean absolute error, and top K categorical accuracy. They are also available in the matrix. So what you want to show here, you can define according to the requirement. And for the activation is also, there are some variants. Mostly you may use the sigmoid, or you can use the softmax, but you can also use some other metrics, for example, like tangent, rel, linear, leafy rel, and etc. So some of the data might work best on the ReLU, but some other data might work best on the leafy ReLU. So it depends on how you want to have your analysis. But most probably for the NLP, softmax will be good. The next is the GRU. So when you do with the Python, I think you can just call the function like the GRU, and then you can define how many layers that you want to generate. So the remaining will be the same. You make the sequential, and then before you put the data into the GRU layer, you will create the embedding. After you create the embedding with the particular parameter, then you go to GRU, and then again make the data dense before we do the prediction. After we dense it, and we want to compile with this parameter, again we use the epoch 100. For the LSTM, it's also the same. We have the sequential embedding with the same parameter, and then we have the number of layers, dense the same, and the compile the same, and the epoch is the same. So let's look at the result. So after we have the model, we want to generate the text based on the trained model. Generating the text based on the trained model means I will take a look what is the model, and then I would like to give a seed. Seed means a text, something that you want to create, and it is based on the model whether the seed will fit to the model or not. And then let's say this one, how many words that you want to generate. So let's see if I have the, so I would like to get the number of words. So the number of words means, how many words that you want to generate. And for every text, let's check the seed text first. The seed text will be checked. And then after we check the seed text, we will do again the pet sequence. So the pet sequence, I think you already know. We want to make the size equal. Okay, so we want to make the size equal, and this size would be based on the token list, and we are making some kind of rule to create the text until the maximum length. And after that, we will make the padding tree. The padding tree means we will make some blank data at first. So the predicted means I would like to check what is the maximum value on the prediction result. So the maximum from the prediction result will be selected, and the output will be based on the maximum probability that has been calculated in the neural network. So we have word and index, because in the neural network you cannot get directly the word. You will get the index. You will get a number. In order to change from the index into word, then you need to see whether the index equals to the predicted index. If the index equals to the predicted index, then we put the word into the output word. And whenever we already have this one, we will create the seed text plus the output word. So the output word will be added. Now, let's see. If I want to generate this one, suppose I have this is, so this is the seed. And let's see, if I want to use the RNN, the maximum sequence length means how many words do we have in the data. So now we have 6. And then I want to generate 5 words. Or in the sentence, there will be 5 words. The second one, I will use the model from GRU. The third one, I will use the model from the LSTM. Then, to do this one, using the simple RNN, we can make a text generation. This is the first document is. So we generate next 5 words by giving the seed this is. The possible 5 next word is the first document is. So this is based on the prediction result. If we use the GRU, when we give the seed this is, the next 5 words are the first document. When you use the LSTM, when we have the seed this is, the next 5 words, the possible words are the first document. So this is using the POI example. Then you can understand, if we have a very big data, if we collect a lot of documents from internet, from any books, articles, magazines, then we can make a very good sentences. So I try to make some text data. So I try to generate some big data. Let's look at the result. So the text data, now we have, once upon a time in a small village, there was a boy named Jack. Jack loved adventures and dreamed of discovering hidden treasures. One day he found an old map in his grandfather's attic and so on. So this is one word, one sentence, and you need to calculate how many words in one sentence. So you need to calculate how many words in one sentence. With the same pipeline, first we tokenize, and then after that we create the input sequences, and then after that we calculate what is the maximum sequence length and then what is the input sequence. So using the same idea, so with the same function, so this is the function. We have the simple RNN, we have the GRU, and then we have the LSTM. So the function of generated text is the same. Now let's take a look on the seed. The seed, now I put once upon something. What is the result? And the second seed is Jack, love. The third seed is the island. So I want to make a text based on these three seeds, and the models are different. So if you look at this one, once upon a time in a small village. Okay, this is a text generated with 5 more words. So after once upon, there will be 5 more words. Once upon a time in a small village. So this is based on the text that we have. Jack loved adventures and dream of discovery. Because we have only 5, maybe the text is not completed. The island was full of strange creatures. So you can see that now the model can generate a sentence and it can create a story. Let's say I want to create something longer. So I do not want the number of words is only 5. So I want to create 10. Or you want to create more than the, you want to create more, but you cannot exceed the maximum sequence length. If you exceed the maximum sequence length, the text will be something not good. So the maximum sequence length here is 14. Then you can see this is a story. Once upon a time in a small village, there was a boy named. Then we can have some kind of story. You can see here, Jack loved adventures and dreamed of discovering hidden treasures. Because of the prediction result, they repeated some of the word. And the island was full of strangers, creatures, and hidden dangers out on. This is also another incomplete sentence. So you can do some other experiments in this text generation. And actually, this is the basic for the bigger model. For example, if you know the ChatGPT. So the idea is from this one. So they have a lot of parameters. They collect a lot of data like this one, and they create the model. And whenever you ask something, and they will create something. And the creation of something is based on your question. Okay, I think that's all for the book analysis. This is the very basic one. And on the next Thursday, I will explain the basic transformer. So it is the continuation of this deep learning before we learn about the pre-trained model.